everyone, in this video we are going to solve the fractional Knapsack problem. So it used an greedy algorithm. So where what it is like what we can take the fractional of items rather than the whole items. If we were taking it out whole item, rather than that we are going to take the fractional of items here. So this was the code for this Knapsack problem, and we'll be seeing the further. So first of all, let me explain the code and we'll see how the algorithm works here. So as we know, this include stdio.h will be your header file, and coming up to the other one. So this is void snap. It is like what int n here. It represents n represents the number of items here. The weight represents the weight of each item. As we know, the Knapsack problem here, it always have the item, weight and profit. These are the three things which it will be contain. You are going to find the capacity. Yes or no? And capacity which is also been given. So profit, P it is for profit, and capacity, that is what total weight of the Knapsack can carry. Okay, so this is what here, this x of 20 is that array that stores the fraction of the each element. Okay, TP is nothing but it is a temporary variable, that is total profit here. So you as the remaining capacity of the snap. So here you are going to initialize the result vector here. So we'll be assuming that is x of this array that is termed as 0.0. That means that no item has been selected. Okay. Next one, we are going to have the greedy fill the snap. So we know the loop through the items by the based on their weights, as we know. So first of all, we'll check if the current item it can be fit in the remaining capacity. So what is why? See, first let me tell you why this been occurs. See, you have the many types of solutions. Under the Knapsack problem, you have many types of solutions. There are not particular solutions that this is. You have many in that minimum cost when they are going to find. Okay. So first of all, let me explain this here. You're going to take it out. We'll check the current item can fit into the remaining capacity. If the current item can fit, then you will be having the wholesome. It is that h of I is equal to 1.0. Okay, added profit to the other one. So this is how it works. Coming to the other part of this is that here we have the fractional section here. So I'll just check it out. If I greater than n, now take the fraction part and you're going to calculate it out. Okay, then we are going to print the results here. These are the results will be printed in this over. And this is the main function, as we all know. Here you're going to get this is the main function as weight. It is weight of the thing that will denote as n, profit, and capacity. Number I it is and j, it is used for loops here, and the ratio of everything. Next, printf, enter the number of objects. You're going to enter the objects, and you're going to enter both weights and as well as profit. This is how. Okay, so for example, this is how this sorting will be. See, first of all, there are several methods. There are 5 steps. We'll just assume it. There are 5 steps. Okay, so first step will be like what? You're going to calculate the ratio. Okay, so you're going to calculate the ratio. It is used. This is the formula of calculating the ratio. Profit divided by weight. What is that? Profit divided by weight. So you have, for example, let me take it out. So 70, 90, 89. So I'll just take it. This is the profit for first one. Next we'll do the same thing for the second, and we'll assume it as 45 and 89, and this is for 2. So this year the 78 and 45 becomes the category of your profit, and 89 and 85 will becomes the category of your weight. So to find the ratio, I'll be dividing it like 89 divided by 89, and the 1 and 2 will be your item number. So okay, this is your first step. The second one is to sort the items by profit to weight ratio. So you have got one ratio. In that wise, you're going to decreasing by decreasing order. On that basis, this loop has been executed. Sort items by profit ratio in descending order. I will be getting the ratio value and you're going to sort it out into a descending order here. So I is equal to 0, I greater than num, I plus plus. So here you have loop, you're going to compare it the ratio of first value. If for 78 and something, maybe the ratio is 49 or something else more than that, I mean in fraction or something else, you have to compare the first one and as well as the second one here. Clear? Because here see, j is equal to I plus, even if it is 0 here, the first one will be considered 0. The second one is 0 plus 1 will be what? 1. So j in the sense of I in the sense of first value and the j is the sense of second value. According to that, it used to compare it out. Okay, then we'll be getting the decreasing order of this one. Then here after you have got everything, and here the function will be calling, and the entire process which I have repeated on the further section will be implemented. Okay, wow. So for example, let me consider a data set. Okay, I'll just up the data set, and according to that I'll explain you. It might be better for you guys. Okay. So I'll have the data set. This is weight. This is your profit. So in the case, this is 10. This is 60. Sorry. 20. 100. 30. And 120. So this is what you have the given table. So in order to calculate the ratio here, first of all, you will be just doing it out for the first one. You will be having the you will be having ratio like what? 60 divided by 10. So as I have told you, it is like what? Profit divided by the weight. You will be getting as 6 here. For the second one is also simultaneously you have to do the same, and you'll be getting the output as 5.0. I mean, for the third one is also 120 divided by 30 will be 4. This is your first step. Step 2, as I have told you, descending order. So what is that? 6, 5, 4. Like this, the same order will be occurs here. So the third step will be like what? Take item 1 fully, that is weight is equal to 10. The remaining capacity will be, as I have told you, it's 40. Then what happens? Then the total one will be your 60. Is it so? Yeah. And you have to do it for the further thing also. So you'll take the fully weight. Weight is equal to 20 for the second one. The remaining capacity will be 20. Yes or no? And if you were like doing it out, then total profit 100 plus the 60 will be your 160. Then the result, after doing all the process, then result vector will be your 1, 1, 0.0. I mean, like you will be getting the fractional part. 1, 1, 0.6667. And the maximum will be your 240. This is how this algorithm works. Let me run and show the program. Oh, sorry, I didn't So first I have to enter how many objects. Let me take 3 and enter the weights and the profits of the object. Let me take the same example. 60, 20 space 100 and 30 space 120. So enter the capacity of weight will be, assume it as the 60. So this is how the algorithm works here, as I have told you. In case if we assume it as something which is like 40, we'll be getting the answer it as wait, I'll just take it out. The same thing, I'll be just seeing it out once again. So I'll just have the thing, I'll just enter 3 and the number of weights and profits, it's 10. 60, 20, 100, 30, 120. And you have the Knapsack, we'll take it as 40, and you'll be having this. These are the thing which you have to know. Okay. This is what I want you to learn it out. And also I want to explain you about the time complexity. Time complexity is that O of n of log n. Okay, this is how the algorithm works, and this is your time complexity. I hope so you have been understand, and thank you.